Hey, what's up everybody? This is Titan from Titans of CNC Academy. So in this video, we're gonna take the model that we drew up in CAD and we're actually gonna switch the software down to CAM and we're gonna take the model and we're gonna actually program the model. So this is actually a setup sheet, which is just like the setup sheets I use in my own manufacturing company. You can actually go into project number 1 in building blocks, go into the folder, click on the setup sheet, download it so you can actually print it out and hold it in your hand, and you can follow along as I've selected 5 different tools that we're going to program today to finish operation number 1 on this part right here. We have a finished part that we drew up at 3/4 of an inch by 1.9 by 4 inches. Our finished stock that we called out is actually 1 inch, so that means that there's a 1/4 inch at the bottom because the part is only 3/4 of an inch, so it leaves a 1/4 inch. Then the stock is the standard rectangle bar. It's 2 inches wide. The part is 1.9, so that's a difference of 100 thousandths. We're going to divide that in half. So we have an excess of 50 thousandths here, 50 thousandths here. We saw cut the material, which you can see on your setup sheet at 4.1. And because the finished part is 4 inches, that leaves us an extra 100 thousandths divided in half. That's 50 thousandths on this side and 50 thousandths on this side. We add a 1/4 inch on the bottom, but I need some material to take off the top. So I'm basically going to skim 20 thousandths off the top, which will leave 230 thousandths at the bottom. I just ran off a whole bunch of numbers, which probably doesn't make a lot of sense, but let's try to simplify things. We're gonna tell the software exactly what I just told you, but we're gonna do it in a way where it understands how much excess material it has, and it'll give you a better grasp on what exactly I'm talking about. So the first thing we're gonna do is we're gonna say, okay, we have a new part and we're gonna program this part. So let's go set up the program. So we're gonna hit setup, we're gonna say new setup, and instantly you can see that there's material added to the finished part. That's the excess material that we're gonna be cutting. So we're just gonna tab right through and fill in the information, and we're gonna set the X, Y, Z coordinates, and then we're gonna tell it exactly how much excess material it has on each side. So it's a milling operation. We're gonna come down to model orientation. I'm gonna click Z and X. So we're basically setting the coordinates for this part and showing how the part is going to sit in the CNC machine. So I want it to sit just like this. So this will be X, this will be Y, and this will be Z. My XY0 will be in the upper left. Right now I can see XY0 is kind of down front and center and halfway down, so I actually have to move that. So we go to orientation, we hit select Z and X axis. Z is highlighted. All I have to do is hit somewhere on the line that represents Z axis, so it's up and down. I'm coming up and down, so I want to hit this line right here. So I highlight it, I click it, and now it's got its edge. Now it went to X. So where's X? X is here. So I come over here and I actually click this line, and you can see the coordinates, it actually rotated. It's not correct yet. So there's a few things that I have to tell the software. So is my XY0 off the rough stock or the finished part, which is gonna be inside, so it's an imaginary line inside like 50 thousandths of this rough stock. So I want it to be off the part. So I'm always thinking part. Basically, when I move a 1/2 inch over, I always want to be thinking edge apart. That looks like a 1/2 inch. That's what I'm measuring. That's perfect. I want my numbers to be absolute. So when it says box point, I'm actually going to click this and I'm going to say model box point. And then you see the little white dots actually went off of stock to model. Then I'm going to click this little dot right here, and boom, my XYZ moved over to location. I'm looking at the orientation. I can see that my Z is correct, but my X is going in the negative direction, even though it's saying positive. So because it has an arrow going this way, that means positive, but it's backwards. So I come back up here, I look at my X, and it says flip X, and I flip it. But then it disappeared. Now it's pointed the right way, but it's back over in this corner. So all I have to do is reselect this dot, and it pops back in position. Now my X is going in the positive direction. My Y is pointed in the positive direction, which is absolutely correct. So it's time to move on. I'm going to hit stock from here. That is your stock material. I need to tell the software how big the raw stock is that I'm actually using. So to make it simple, I'm going to make a couple adjustments. Up here, I'm going to say add to all sides, because I want you guys to understand that there's excess material on all sides. Okay, so we have a few shortcuts, but right here, I'm going to hit add stock to all sides. And what this is going to allow me to do, it's going to allow me to add 50 thousandths all the way around the perimeter in X and Y, but it's going to allow me to add just 20 thousandths to the top and then 230 thousandths to the bottom. It's going to hit all sides. I'm going to click X. I'm just going to tab right through it, 0.050, X positive, 0.050, tab through it, negative Y, 0.050, positive Y, 0.050, Z negative, 0.230, Z positive, 0.020. By adding all the exact numbers to each side on X, Y, and Z, it gave me my total width dimensions. And guess what? My height is 1 inch, which is my stock size. My Y is 2 inches. And my X, which they're saying X axis, the width is 4.1, which is the exact part that I cut right here. So the software knows exactly how big the material is, and you can see the part inside the material. The software always knows how much material is on the part. So when I take a cut, it knows it took 20 thousandths or 50 thousandths or 230 thousandths when I flip it over, and I can take additional cuts because it knows the exact amount of material left. On this, we're not going to post-processing yet. That's at the end. So I'm just going to hit OK. I'm ready to program now. The stock looks perfect. I'm gonna have a vise that'll be holding down here, holding the stock down here. So the first thing we're gonna do is we're gonna cut across the top. Boom. That'll be tool number 1, which is my 3-inch shell mill. So I'm gonna simply come up here. I'm gonna hit face. I'm gonna go grab tools. One of the cool things that we did with the Academy is we standardized tooling. So when you click here, boom, you can see 16 tools. So we actually created a standardized tool list where all these tools actually build all of the building blocks. And Kennametal has an Academy toolkit for over 50% off. So get the toolkit, then go into Titans of CNC Academy, download the tool list, upload it into Fusion, and you can actually select the exact same tools that I do. So this is the tools. I'm gonna go to tool number 1. I'm gonna click this guy. I'm gonna say okay. Now it automatically gives me parameters and speeds and feeds, right? So it says 10,000 RPMs. I'm gonna slow all of this programming down. I got a lot of students that are watching and they have machines that might only run at a few thousand RPMs. So looking at some of the smaller machines, I'm going to program everything at 4,000 RPMs. And then at the end, when we cut the metal, I'll do it at 4,000 or below. And then I'll do another sample running at 10,000, and we'll look at the time it took to actually run it on this machine versus the time it took at the higher feed rates and spindle rates to see how much time we're actually saving. So right now I'm going to change this to 4,000. It automatically changed my surface footage. My ramp spindle speed is exactly the same. My cutting feed rate that I'm using to actually cut the material, I'm going to slow down to 25 inches per minute. It changes my feed per tooth. My lead-in feed rate, I'm just going to keep them all 25, ramp 25. We're not using any of it at this time, but I'm putting it right in place. I'm going to select the geometry. It shows the stock contours. There's nothing selected, and it shows me a yellow line around the box right here. And it's basically saying you're going to cut and face everything inside that line. And I'm in agreement with that. Now I'm going to come to my heights. When you guys see it, your defaults will be set to something different. So it might say clearance or stock material or retract. What I like to put on all the different heights is model top. It's just an absolute position. I know the Z top, the surface top of my part, and I understand the depths I'm dealing with. And if my tools are above it, and like say I come down within ½ an inch above the part, I want it to say model top. Then when the tool's at a ½ an inch, I can say, this is where my Z surface, the top of the part is. The tool looks like it's at a ½ an inch above. It's an absolute position that I can really look at and say, yes, that's good. It's not going to crash. It all makes sense to me. Basically, what I'm saying is, what I like to do is go model top on everything so that wherever the Z is at any given time, I can see how it relates to that top surface. So the first clearance height, going to model top. One of the cool things about Fusion 360, it'll give you a description of what exactly it is that you're doing, or the description of the box that you're actually filling out. So 0.4, then I'm going to go to the retract height, where it actually retracts before it makes the movement. I'm going to say that's 0.2. Then I'm going to say feed height. I'm going to put that at 0.1. That means like, okay, it came to 0.4. Now it's going to drop down to 0.1 before it starts feeding into a cavity or feeding into anything, right? So I'm going to put that at 0.1. And then the top height is the model top with an offset of 0, meaning the top of the model, that's Z0. The bottom height is the depth of cut. I don't want to go below. I don't want to be above. So it's model top, and it's also at offset 0. So that looks great. I'm going to move on to my passes. My tolerance, right now I'm just facing. It doesn't even matter. You can actually read the description of tolerance. I use it when I'm trying to do something that's really fine tuning. So we'll actually put a nice small number in there so it actually makes the perfect surface, right? So right now I'm going to leave it alone. It's at 4/10. The pass is going to be at 0 degrees. The pass extension, the tool is going to drop down, and it's a 3-inch tool. So half of the tool from the center of the tool out is 1.5, right? So it knows it has a 3-inch tool, so it's going to offset the center off the part so it drops down into air, and then it's going to start cutting material. But once it gets to the edge, and it's center of the tool to center of the edge, it's going to stop. But if it stops or starts arcing out, it could leave a line right there. The surface finish here will be different than how it started over here. So what I'm going to do is I'm actually going to have it come off the part until the entire tool has disengaged the material. So right here on pass extension, 1.5 would be off the part, meaning the center of the tool is off the part by half the diameter. And then I'm going to do just a little bit more. So I'll do 1.6. That's half the diameter plus 0.1. The step over doesn't matter because it's a 2-inch part with a 3-inch face mill. So I'm going to take it in one pass. Direction doesn't matter because I'm only taking one cut. So I'm going to leave it alone at both ways. I'm going to leave everything alone. It all looks perfect. I'm going to come up here to linking, which is my last tab. Looks fine. Allow rapid retract, looks fine. Keep tool down, looks fine. Maximum distance, that's just saying when you're in the cut and you're moving around, what's the maximum you can actually move around? In this case, it doesn't even come into play, so I'm just gonna leave it alone. We're coming into lead ins and lead outs and transitions. We have a 0.3 radius. I'm gonna just leave that alone. As far as a vertical lead in, everything looks fine. So I'm just going to hit OK, and boom, it just made the tool path. So I'm going to look at the tool path. I can see that the tool comes down here, it arcs in, moves across, it's off the part, and it arcs up. If I wanted to, I can actually go in and make adjustments to the tool path. So just to show you how I would do that, face mill, let's just make that radius a little bit smaller. So I right-clicked it, I'm going to hit edit. I'm going to go back to linking. I'm going to go to the lead-in radius. I'm going to hit 0.050, just a small little radius. Boom. So then I hit OK. And all of a sudden, you can see that the radius is much smaller. So it just drops down, has a slight little radius, shoots across the part. I can flip the part around, comes up, it has an arrow. This is the direction it's going. So it came down, came across, and now it's up. So now I'm going to look at tool number 2. This is a 3/4 inch diameter 3-flute end mill. I have a flute length of 1 inch so that I can actually drop down 750 or 760, just overtake it a little bit, and walk around the part. So the cutting flutes, the length is actually 1 inch. So when looking at roughing this entire part, how can I rough it the fastest? Meaning I have to cut around the outside, I got to cut the cutout, and I actually got to cut the pocket. There's different level changes. So even though this is a simple part with just a few level changes, the easiest way to do it is actually going up to 3D and hitting adaptive clearing, because it sees the entire part and it knows where to go. Once I establish certain perimeters and fill in all my boxes, it'll know exactly where to go, and it'll cut the inside pocket, the cutout, and the outside all at the exact same time. So I'm going to hit adaptive clearing. I'm going to go in and grab my tool. We're going to come in, click this bad boy again, and we have a 3/8 end mill. All right. So we're going to come down 3/8 right there. Hit OK. Now that our tool is selected and I can see that the coolant is on flood, I'm just going to go down and I'm going to start tabbing through and setting all my speeds and feeds. And then I'm going to walk through all the tabs like we did on the previous tool. I'm going to hit 4,000. My feed rate is going to be 25. I'm just going to make my lead in feed rate 25, lead out 25. My ramp, I'm going to put it 15 so I can adjust it. 15, and now I'm ready to go. When you're looking at your ramp feed rate, I know that I'm going to helical into solid material, so I set a different value, a different feed rate, so that when it helicals in, it goes a little bit slower than it's actually feeding. Now that this looks good, I'm going to go up to my geometry and adaptive clearing. I'm actually going to leave the machining boundary as none. I can see the yellow line around here. It already knows where the part's at, and it knows that it's going to rough everything possible within those lines. So on contours, I'm not going to select anything because it will rough everything possible. When I look at my part, I have a pocket, I have a cutout, and I have the outside, and I want all of those surfaces to be cut at the exact same time. I'm going to leave rest machining on. And that basically is calculating all the material that's already been removed. So if I had already gone into the pocket and I'd left some meat in the corners, Rest machining would know that there was a larger tool that went in there, there was some meat left, so it wouldn't worry about roughing the entire pocket. It would just drop into the pocket, go and actually take out the excess material if it was a smaller tool. So that's a genius function right there. In this particular case, it knows that I face the top, so it's not going to bring my end mill up and do any roughing on the top surface, and that's why I care about it. So I'm gonna say everything's fine. I'm gonna go to my heights, model top, all the way through. My clearance height, 0.4, retract height, 0.2. My top height is 0. My bottom height, I want it to actually drop all the way down to 760. And you can see that my height's already adjusted right here. So the blue is where my tool's coming down to. I'm gonna come up and I'm gonna go to passes. There's my tolerance again. I'm just roughing. Shallow areas, I don't have to worry about that right now. That would be like if I had just some tiny little pockets that were like 20, 40, 60 thousandths deep and I wanted to rough those within about 10 thousandths, I really don't care, okay? So I'm gonna leave that alone. My optimum load, I'm gonna change that. It's a 3/8 cutter. I'm going all the way to the bottom. So I'm gonna say 0.100 thousandths on the diameter will be my optimal load. Minimum cutting radius, I'll actually drop that down. Machine cavities, yes. Use slot clearing, it's a special way of clearing slots, so I'm not gonna worry about that right now. Direction, climb cutting. Maximum roughing step down. That means if I'm dropping down 500 thousandths in the pocket, I can say, don't go more than 100 thousandths or 200 thousandths. In this particular case, because I'm gonna ramp all the way to the bottom and take a smaller radial, I'm just gonna go straight to the bottom so that I use my entire tool at a 1/2 inch deep. And I'm gonna say maximum step down is 0.8. Why did I hit 0.8? Because my depth was 760 and I didn't wanna take that in a couple stages. I just wanted to take it one shot. It knows that my pocket is a 1/2 inch deep and I'm gonna leave material on it so it'll already know how deep to go. So I put 0.8, it's perfect. Stock to leave, I'm just gonna say 10 on the bottom and the sides. Come up to linking, full retraction, high feed rate mode. It all looks good. Rapid retract, looks good. Stay down distance, looks good. Minimum stay down, don't need to worry about any of it. Now stay down level, I'm actually going to put about 70%. So why would I put 70%? Here's the reason. If I said stay down level and I said most, when I actually machine around the part and then came back to say do a cutout on the sides, it would stay down and like literally walk around the part without lifting up because it knows that I want it to stay down most. By me saying, say 70%, it'll actually walk around it and it'll lift up, wrap it over, then drop down, which is the quickest way to get from point A to point B. So 70% will allow it to rapid. Lift height is when I'm coming in, I'm making a cut on that tricordial tool pat, it comes in, it actually comes out, it's not in material, and it feeds again, comes out, feeds again. Every time it comes out and it's in free air, free motion, you can actually choose to lift it a hair. Right now I'm not gonna worry about it, I'm gonna leave it at 0, but because I'm not cutting anything, I'm gonna go faster. So on this particular one, I'm gonna go 100 inches a minute, just saying when you're not cutting, but you're still in feed rate mode, go 100 inches a minute instead of 25. Lead in radius, 0.3. I'm gonna just make it a little bit smaller, maybe 150, 0.150. Ramping, I'm doing a helix, 2 degree. I'm using a 3-flute tool. It can handle a nice ramp. I'm not gonna go too aggressive though, we're teaching, so I'm just gonna put 4 degrees on the ramp angle. On the helical ramp diameter, that's the diameter that I'm actually helicaling down into the pocket. So I have a 3/8 tool, So center to center, as this thing ramps down, I just want it to be a little bit smaller than 3/8, meaning 0.375. So I'm going to say 0.350. I'm going to say minimum is like 0.3. Everything looks good, so I'm going to say okay. It's calculating the adaptive clearing rough passes, and there you go, all your tool paths. So basically what we see is that it's going to drop down over here, it's going to helical in to the pocket, it's going to run the entire pocket, roughing, leaving 10 thousandths. Then it's going to come over here, it's going to actually rough the side, then it's going to drop back over here, it's going to actually profile the entire part and lift up. So we can simulate this. I'm going to right click on this tool path. I'm going to hit simulate. You see this box that pops up over here. I'm actually going to say yes, I want to see the stock. I want to see the tool path. I could make it transparent if I wanted to, which makes it transparent, but I'm actually going to leave it alone. And let's go down here and press play and see that tool path. So it's cutting the outside, coming around the front. I'm actually moving it. It steps up. Makes a cut right there. Boom. Now it's going to drop down. I'm going to speed it up. Now it's just going to town, roughing the entire part. Boom, looks good. All right, so we got a lot of confidence now. So we already faced it. We did an adaptive tool path, which we roughed out the center, roughed out the edge, walked around the entire part. Now we're ready to go. I'm going to close this window, go back to the solid model, which shows the tool path of the last tool. And now I'm going to come in here. I'm actually going to start finishing the part. So I'm going to come into 2D now. I'm going to drop down and actually just do a 2D contour. Everything looks good. My geometry, there's no contour selected. So I'm just going to hit down here. I'm going to actually select, and you see everything highlighted. I'm going around the outside of the part. So I'm going to click this line and I'm ready to go. I hit heights. I'm going to hit 0.4, retract 0.2, feed 0.1, model top is 0, and the depth of the cut is negative 0.760. Looks good. Say my passes. Now I'm doing a finished pass, so having it at 4/10 is perfect. We're climb cutting. We're doing cutter comp. When we do cutter comp, adding a G41 to it, I'm going to actually hit where, which is going to allow our post to create the cutter comp exactly how we do it, where it's center of the tool, which is off the part, and it does the G41 with a D value, goes around the part, comes off. So you have the compensation allowance, the radius allowance. I'm going to say that that's fine. Make sharp corners, no. Multiple finish passes, no. Feed rate, finished feed rate, 25. That's what I had it at, so I'm going to just leave that alone. I'm not adding any overlapping. I'm not adding anything. I'm rolling around the corners. That's fine. I'm going to come down. There's no roughing passes, no multiple depths, no stock to leave. I don't care about any of that. So I'm just going to go straight up to linking. My high feed rate, I'm going to leave it. Allow rapid retract, I'm going to leave it. Safe distance, 39 thousandths. I'm going to leave that. If you remember, if you click it, it'll actually describe exactly what you're dealing with right there. So for this part, I'm just going to leave it alone. None of this comes into play, so I'm going to drop down to my transitions. My lead-in radius is 37 thousandths. My sweep angle, I'm actually going to change this to 45 thousandths. I just like the angle that it comes in on. If you hover over it, it'll actually show you the difference between a 90 and a 45. Sometimes I go 30. I just come in from that angle, keep that pressure off. It's just something that I do. So the linear lead-in distance, which is in addition to the radius, is 37. I'm just going to put 0.1 just to have it nice and safe, have it off. I actually do not need a vertical lead-in, so I'm going to hit 0. I'm going to say everything looks good right here. So here's the first time that I'm actually going to specify where I want my tool to come down. And I know that my part is actually going to be on the vise, and I don't like how tools come down in the back where you can't see them. So in this particular case, I'm going to click the front on entry level. I'm going to hit entry level, and then I'm going to hit right here. I'm going to click it, and then it's going to tell the software to actually start the tool on this side so that when I'm looking through the glass, through the door, I can actually see the tool drop right here. I can see that everything looks perfect, have confidence that my cut's going to be dialed. All right, so we're ready to go. I'm going to hit OK. Just like I said, you can see it drops down right there, feeds in, walks all the way around the part, looks good, feeds out. So now what do I have to do? So now the part is perfect to size. Now I've roughed it, I've finished the outside. So now I have to finish this pocket and finish this pocket right here. So let's do that by actually creating a 2D pocket. So I'm going to hit pocket. My tool is already selected. My RPMs and feed rates are already selected. I'm going to go to geometry, pocket selections. So I'm going to come down here. I'm actually going to go to the bottom of the pocket. It'll highlight the entire pocket. I'm going to say OK. It makes everything blue that I'm machining. Then I'm going to come down to the cutout, and I'm going to click this guy, and it makes everything blue. And I'm going to go on to heights. Then I'll come up to the heights, model top, model top. I'll hit 0.4, 0.2, 0.1. Model top is 0. Now the deepest point that I'm actually going to go down is 0.5 because a pocket and the cutout is actually 0.5 deep. You see it right up here on the print. So on here, I'm going to go negative 0.5 because I don't want it to go 760. The deepest it can go is 0.5. Let me hit passes. I got on my tolerance, I got some nice contours in here, so I'm actually going to take this down to 4/10. I'm climb milling. Minimum cutting radius is 0. I'm not going to worry about finish passes because I'm finishing the bottom and the sides in this movement right here. Maximum step over, it says 356. Maximum step over, meaning how far it steps over each time it takes a cut. I'm going to leave it alone at 356. I'm not going to worry about morph spiral machining. Click allow step over cuts. That means like if you're in a radius and you're stepping over and stepping over, you can actually leave a little divot that actually sticks up, a little cusp. So we'll not be clicking this box. Smoothing deviation. Again, I'm just going to click 4/10, just so it's nice and beautiful. No multiple depths, stock to leave. I'm finishing it now, so I'm going to unclick that. Everything looks absolutely perfect. I'm going to click linking. As I walk through here, everything looks perfect. Stay down distance, 2 inches. It really doesn't matter right now. Remember now, everything's been hogged out. So I'm just dropping in, and I'm basically just radiusing in or ramping in to the cut, finishing the part and getting out. I'm going to leave 37 thousandths on the radius. My angle, I'm just going to change it to 45. Leave 35. My vertical lead-in radius, the same thing. I'm going to leave it alone. I'm going to leave the exit as the same as the lead-in, so both boxes are perfect. When it comes to ramp, I don't need to ramp all the way down because the material is already gone. So I'm going to plunge, and it has a ramp clearance height. So I'm basically going to plunge down, and then it's going to go right into my radius, which is going to go right into the wall, which is going to make a perfect cut. So I'm going to leave that alone. Drill positions on this, doesn't really matter right here. I'm going to click OK, and boom, there's our finished pass. All right, guys, so we just finished tool 2, the 3/8 end mill. Now we're going to chamfer the edges, just break that edge so it's not sharp, nobody's getting cut. And then we're going to use the same 1/4 inch chamfer mill, tool 3. And we're going to spot each hole that we're going to drill and thread. We're going to go 2D chamfer. I'm going to go select tool number 3. We're going with a 1/4 inch chamfer mill, 4,000 RPMs. I'm going to drop down here, 25 inches a minute, nice and safe. 25 inches a minute, 25 inches a minute, 25 inches a minute. I'm going to hit geometry. I'm going to select the outside. I'm going to select the inside for our contour selections. So I'm going to climb on the outside, drop in here. My arrows, they're going in the right direction. Everything looks good. I'm going to go over here to the heights. I'm going to hit model top. I'm just going to go through and do all of them. Model top, I'm at 0.4. Retract, I'm at 0.2. Feed, 0.1. 0, 0, because I'm at the top. I'm only doing the top, so I want my Z depth to be right on the top surface. It'll know exactly how to offset it. 4/10 is okay. I'm going to put cutter comp. I'm going to put wear, so I have my G41 line. I'm going to come down my chamfer width. The chamfer that I'm putting on the edge is going to be 10 thousandths. My tip offset is going to be 0.05. So it's a 45, so it comes off 50, drops down 50, and then anything beyond that will be your chamfer depth. So 50 thousandths. The clearance right here, it doesn't matter on the top because I'm not going to hit anything, but once I drop down here, I'll use it so I don't hit that edge. So right here, I'm just going to say 0. I'm going to go to linking. Everything looks perfect. Coming down, say 0.025 on my lead-in radius. 90, I'm going to do a 45. Everything looks absolutely perfect. Hit this guy. Boom. So you can see that the tool actually comes in, it arcs in, moves in, radiuses in. So the cut looks absolutely perfect. Everything looks good. Something that's pretty easy is I can actually come down here, actually duplicate. It duplicates it, the tool path, and then I just come over here and edit the tool path. And then when I come over here, everything's exactly the same. I can hit geometry. Boom, I get rid of these two. I can just hit this guy down here. Just a nice little shortcut, right? So now I'll come over here to heights. Everything's exactly the same. Come over here to passes. I'm going to leave everything the same except on the bottom. I don't want to hit here. So the tool, we're using the bottom of this tool. So the tool diameter is actually bigger than the cutting surface. So if I was to come in and hit it right here, I'd actually hit that part. So because the software knows the tool geometry and the solid part, I can simply say, stay off of here 50 thousandths, and it will do exactly that. It'll just start over just a little bit so it doesn't hit. Go back to linking, everything is exactly the same. All right, so next thing we're gonna do is we're gonna actually go and spot these holes right here with the same tool. So I'm gonna just come right up here. I'm actually going to hit drill. Now since we're bringing that tip straight into material and it's a chamfer mill, I'm just gonna slow it down just a little bit. Okay, so I'm gonna bring it down to 10 inches a minute. 10, 10, 10. I'm gonna come up here, I'm gonna hit geometry. All right, so now we're dealing with drilled holes. So it's a little bit different. So here we can actually select faces or select points. So I'm going to select faces. I'm going to come down here and I'm actually going to knock this guy right here. Boom. Okay, then I'm going to come to the next one. And then I can go to the next one, the next one, and the next one. But I want to show you something. If you look at select same diameter and click this guy, it automatically hits all the same diameters. And then you hit optimize order, and it'll actually start here and go the shortest route right there. So everything looks absolutely perfect. I'm gonna hit heights. I'm gonna keep model top. So on the clearance, I'm going to keep it at 0.4. Go up 0.2, 0.1, 0. All right, so now we have all the heights set. But how deep are we going? So we have a 45, a 90 degree included angle. As we go down, if I go 50 thousandths, it's going to open up to 100 thousandths diameter. If I go down 100 thousandths, it'll open up to, if I go down 100 thousandths, it'll open up to a 200 thousandths diameter. So I have a 1032 thread that I'll be putting in each one of these holes. That's 0.19 diameter. I'm going to add about a 10% chamfer on the outside of it. So the lead for the thread is what we're creating right now. So I'm going to add, say, plus 0.020. It's like 19 thousandths would be, but I'm just going to put like 20 divided by 2 equals 105. So 0.105. So we're going to make our depth right here negative 0.105. We're going to go up to our cycle. We're going to keep it right here. We're just going to go drill because I just want to like drill in and wrap it out. I'm going to press OK. All right, so now that we spotted each hole to make way for the drill, so the drill goes in nice and straight, we're actually going to program the drill. It's tool number 4 on your setup sheet. It's a 177 drill, which is the pre-drill size for the thread. So I'm going to come back up to drill. I'm going to select my tool. We're going to a 177 drill. We're going to OK it. Put it at 4,000 RPMs. I'm just going to feed in at 15 inches a minute with my drill. My retract rate is 40. Select faces. We're already there. I'm going to grab this guy right here. Select same as diameter. Go back to my heights. Model top. So 0.4, 0.2, 0.1. Now, how deep do we go? So the model top, we're actually going to offset. So the thread, it calls out for a thread that's 0.380 deep. Every tap actually has a lead. A good way to measure that lead would be going on a comparator, actually standing it up, zooming it, and looking at where the full thread diameter starts, And then you can see that diameter right there to the tip of the tap. That distance is your lead before your thread actually starts. So I need to drill with a .177 drill deeper than I tap to make way for that lead right there. I'm gonna go 200 thousandths deeper. So instead of 380, I'm gonna go negative .580. All right, so now we're coming to the cycle. We're actually gonna come up here, we're gonna go down, we're gonna hit deep drilling, full retract. That means the drill's going to drop inside, engage the material, come out, get the chip out, allow coolant to get into the hole, and then drill again, come out, coolant goes in, chip comes out, drills, boom, boom, deeper and deeper. I'm just gonna leave 50 thousandths. You can actually reduce your PEX. So if you go 50 thousandths, the next one you could go 40 or 30, but I'm not gonna do that. I'm gonna keep that at 0. My minimum right here is gonna be 0.05, exactly the same. I could dwell at the bottom and let it sit for a second, but I'm not gonna do that either. And boom. The last tool we have is a 1032 roll tap. It's a right-handed tap, basically going in clockwise, creating the thread and coming back out. We're gonna actually hit drill. All right, and for our fifth and last tool, we're gonna drop down right here in this right-hand tap, right here, .192. This guy is a 1032 roll tap or form tap. But when you jump over to the Rocket, which is the lathe series, we're gonna have all cut taps. So you're gonna learn about both types of taps, use them both through the 2 series. All right, so we got it. Let's go ahead and click it. Boom. There's my tool. I'm gonna keep it at 1,000 RPMs. I'm gonna come up to the geometry, select, selected faces. I'm gonna do the exact same thing I did before. I'm gonna click down here. I'm gonna say same as diameter that I already selected. Hit that. I'm gonna go to my heights right here. I'm gonna change all these to model top. .4. Retract. I'm going to keep it the same. .2. Feed height 0.1. The top height is 0. We're going to say bottom height. We drilled at 580. I'm going to tap at 480. So I'm going to go negative 0.48. Go up to my cycle. It says tapping. I'm actually going to come down here and click right hand tapping. So boom, there we go. The program is done. Let's go right up here, actually simulate the entire part, okay? So let's go through all the movements. So I'm gonna come over here. I'm actually gonna turn transparency off. Move this around right here. I'm gonna hit go. We're facing the top. I'm gonna speed it up just a little bit. So that's tool 1. Tool 2, 3/8 end mill, going around. Drops on the side, does the cutout. Boom, boom, boom. We're roughing it, leaving 10 thousandths. Helicaling in, down into the pocket. Now we are roughing the pocket, leaving 10 thousandths on the bottom, leaving 10 thousandths on the sides. We're going to town right here. Everything's looking perfect. Now we already know that we're expecting that same tool to come over and do a finish. Boom, there's a finish. There's a finish. There's a finish on the inside. We flip this thing around so you can see it. There's a deburr, the deburr on the outside, deburr on the bottom, spotting the holes right there. Now we're drilling 580 deep, drilling the holes. It's so exciting, it looks perfect. And then we just have our 1032 roll tap. This is gonna come right after it. Boom, threading, 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 threading. Whoo, mission complete. We got our part. All right, so now that we have a part, now that we've simulated it, we got to create the code. So when you look over here, you can actually see all your tools, right? But they're out of order because we pulled them right from the building blocks tool library. All right, so this is tool 1, tool 3, tool 15, tool 10. But that's not how I want them to actually go into my CNC machine. I want it to be in order. All right, so how do we do that? This is how we do it. I'm going to do it on the first building block to teach you guys, and you guys got to get it right now because I'm not going to explain it again. Okay, so boom, it's right here. We come up, see this manage right here? We come up, we click tool library, boom. All right, so now you can see where we got our tools from, right? If I click this, you see this is our tool library that we got the building blocks. But this up here in documents, this is actually all the tools right here, and they're out of order, okay? They're actually backwards, so like it'll be like 1 up, right? So what do? We actually come over here, renumber tools. I'm gonna click it. It says first tool number is 1, increment 1. Everything, and then you can just come right through here. Everything looks good, boom, boom, boom. We wanna make sure that everything matches. So when you go into the CNC machine, you're gonna have height offsets, and you're gonna have the T number, and if it's a T1, it has to be a height offset 1, and then the diameter offset 1. It all has to match perfectly, okay? So this is correct, this is correct, this is correct. Now watch it, I'm gonna hit this, and then watch what happens up here, okay? I'm gonna hit this, boom. 1, 2, 3, 4, 5. All right, so everything is in order. I'm going to X out here. Boom. Okay. Now look from the top. 1, 2, 3, 4, 5. All right. So now we have all of our cuts. How do we actually turn it into the code that the CNC machine reads? This is how. Right here. Boom. I click this guy. So when you look right here, this is actually my post right here. All right, you see the information right there. So when I click it, inside my Fusion, I run these for the Haas machines. So I have a Haas UMC 750 post, and then we have a vertical. This it doesn't say it, but this is my vertical, my 3-axis. So 3-axis and 5-axis. So today we're running a 3-axis. If you guys are running a Mazak, you guys are running an Okuma, you guys are running something else, basically you guys will load whatever post that they give you, that Autodesk gives you for that machine, you'll load it into your system and it'll show up right here, okay? So I'm gonna click this guy right here. I'm gonna come down, everything is perfect, part numbers right here. This is old, so I'm just gonna say Titan-1M right there, all right? And then when you look at this box right here, the first time that you actually use your post, you can go down and you can actually change the different feed rates. Like I have 800 right here, right? Because my high feed rate is 833. So whenever I'm looping or doing something, I might be feeding at 100, but my high feed rate is 800. I want it to be quick, so I actually overrode the previous number, put it at 800. If you have a machine that only feeds at 300, then just put like 200 or 300 here. All right, so when you're all finished right here, you're just gonna click post, boom. All right, now this is your number. Now you're gonna go down and find your USB key. So this is my USB key. I'm gonna click this guy right here, and I'm just gonna hit save. Boom, we got some code. I'm gonna pop the USB key into the machine. Thank you very much. Boom.